All right, everybody. I need to do a matrix operations video with you so you can see what's going on. And I'm just going to tell you up front the operations that we normally do with our matrices are add, subtract, and multiply. And I am starting to wear myself out here, and I just feel like I'm not going to make as good of a video. I'm more likely to make mistakes if I do all three of those because I don't have time. So, what I'm going to do is I'm going to split this video, and I will do add and subtract right now, and I will do multiply later. And you will get that video so that you can complete your homework. But I'm not going to make that work out tonight for me. I don't think. I'm starting to drag, and I apologize for that. It's just it's been a long weekend and a long week. Okay, so I will deal with multiplication stuff later. It'll be fun. So I'm kind of looking to see what I'm cutting short then. Okay, so with that said, well, how in the world do I add and subtract matrices? And the answer is to add or subtract a matrix. Let's say two matrices. Okay. The matrices have to have the same size. And we call it the same elements. Okay. And by that, we mean they have to represent the same things. Okay. So, in other words, if I had a matrix that had X's and Y's, and I had another matrix that had Y's and Z's, I can't add those because their elements don't represent the same thing. Okay. But if I have one matrix that's X plus X's and Y's, and I have another matrix that's X and Y's, and their sizes are the same. Okay. That's important. Same size, then I can add or subtract them. Okay, that's the key point here. All right. So, what does it mean to be the same size? Okay, and the same elements. Well, what we can do is, um, let me give you a matrix: A, B, C, D, E, F. Okay, and say it's equal to 1, 2, 3, 4, 5, 6. Okay. So before I get into adding and subtracting, can I do this? Are they the same size? Can I say they're equal? And the answer is yes. Okay. What I've got to be careful about is I need to match these up element by element. Okay. So, in other words, A is in the top left corner, or we would say the first row and the first column. Okay. And your homework might actually call it like this is the 1 1 position. First row, first column. Okay. A is in that position. What element in the second matrix is also in that position? The 1 is. For this matrix, this 1 is in the first row, first column, right? Okay. So when I have two different matrices and they have the same exact size, if I set them equal, then what happens is they're called corresponding elements. Okay. This guy and this guy correspond. They're in the same exact location. Okay. And if that is true, then we can say they are equal in this case. Okay. So here I can say A equals 1. Absolutely, because they're in the same spot. What about this B? He's in what position? First row, second column. And normally I'll go all the way across the rows first and then work my way down. Not always, but normally. Okay. First row, second column. So can I say B equals, what do you think? First row, second column. B equals 2, right? Absolutely. And then I'm going to circle this one, the C. What position's he in? First row, third column, right? He's in the 1, 3 position. So C equals what? First row, third column. That's this guy. I'm going to circle him also. Okay, absolutely. Okay, so if they're in the same corresponding positions, then sure enough, I can set them equal. So I think that D equals 4. I think that E equals what? I'm going to squiggly line it. 5. And what do you think F is? F equals 6, right? Okay. So absolutely we can do that kind of thing. That's my example for, hey, if two matrices have the same size and we set them equal to each other, then we can set them one element at a time equal to each other if we want to. Okay. Real quickly, what's the size of this matrix? How many rows? 2. By how many columns? 3. So sure enough, that's a 2 by 3 matrix, right? Okay. I think on the quiz I said something about a 2 by 4, so a piece of lumber or something. What size is this guy? How many rows? 2. How many columns? 1, 2, 3. 2 by 3. So they are the same size. Okay. So I can set them equal, or like I started to say earlier with my operations, I can add them or I can subtract them. Now I'm not going to add these and subtract these because one's a variable and one's not. But let's get another example. Okay. Example. We have one matrix that says, well, let's do it with variables first, and then we'll make it nicer with numbers. This is what we find out. If I have matrix, excuse me, A, B, C, D, and I want to add it to matrix W, X, Y, Z, okay, before I do anything else, I need to talk about the size of these matrices. This is a 2 by 2, 2 rows, 2 columns, and this also has 2 rows and 2 columns, okay? Okay, so what it says is, what this little theorem or whatever says, is if I have that, then I can add the elements that are in the same position, the corresponding elements, and put them in the same position. So A plus W is going to go right here in the 1, 1 column or 1, 1 position. What do you think the B is going to be added to? B plus X, right? Those are in corresponding spots. This is in the first row, second column, first row, second column. So my answer is going to go first row, second column, B plus X. Okay. What about here? It's going to be C plus what? C plus Y. Those are in corresponding positions. And D is going to be added to Z, right? Okay, so that's the idea. And when I finish my answer, whenever I've added or subtracted, better be a 2 by 2 matrix. So all of these things, when I'm adding and subtracting, their sizes end up the same. Okay, their sizes are the same. Okay, cool beans. So here's what goes with that. You can add or subtract elements in the same position. The answer goes in the same position of your solution matrix. Okay, you can add or subtract, I'm gonna put it right there, elements in the same position, as long as they're the same size matrix to start with. The answer is going to go in that same position in your solution matrix. Okay. All right, so that's the idea here. We're going to give an example. Okay. This example says you've got a matrix. The row is 2, -3, 0. The second row is 1, 2, -5. And the problem asks you to add the matrix 3, 1, 2 on the top row. And the second row is -3, 2, 5. Okay. So what do we think? The first row, first column is going to be 2 plus 3 is 5, right? Oh, I'm sorry. Before I went on, 2 rows and 3 columns. This is a 2 by 3. And 2 rows and 3 columns. This is also a 2 by 3. So can I add it? Yes. Okay. 2 plus 3, those are in the same spot. That's a 5. -3 plus 1, that's -2. 0 plus 2, that's a +2. 1 plus -3, -2. 2 plus 2, that's a 4. -5 plus 5 is a 0. What is this? What size is that matrix? My solution. It's a 2 by 3. So sure enough, they all match in size. I can do it. That's cool. Okay. All right. How about this example? All right. We got 3, 2, -1, -1, 0, 3. Okay, so what size is that? How many rows? 3 by how many columns? 2, right? Okay, and I want to add that to -2, 3, 1, -1, 2, -2. Okay, how big is this guy? 3 by 2, right? 3 rows, 2 columns. Can I add them? The answer is yep, you better be able to add them. Yay. And my answer better end up being a what? 3 by 2, right? Okay. So first row, first column, 3 plus -2. 3 plus -2 is a 1. 2 plus 3 is a 5. -1 plus a +1, that's a 0. -1 plus -1, that's a -2. And then 0 plus 2, that's a 2. And 3 plus -2 is a 1. Okay, check my arithmetic, but I'm pretty sure I'm right. And what's this guy's size? 3 rows, 2 columns. So he's a 3 by 2, right? Okay. So that's how that's going to work. It goes pretty quickly once you know, okay, I know how big my matrices are and all that kind of stuff. Okay. Here's another example. See what you can figure out. Top row is 5, 0, -2. Bottom row is 1, -3, 8. And we're adding that to top row is -1 and 7. The second row is 0 and 6. And the third row is -2 and 8. Okay. What is that? Okay. Think about it for just a second. I'm looking at it, I'm kind of going, that looks a little weird. Okay. All of the others lined up nice and pretty, but this one doesn't line up pretty, right? That was pretty. This is pretty. This guy's not pretty. Why is this not looking right to you? I hope it doesn't look right. The first matrix is a 2 by what? 2 by 3, right? Okay. The second matrix, how many rows? 1, 2, 3 by how many columns? 2. Okay, 3 by 2. Are those the same size? No, not the same size. Okay, can I add them? No. So what are you going to say? Cannot add. Or you could say no solution. If you wanted to use the no solution notation, you put the 0 with the slashy through it, that's fine. But we know, hey, I can't do that, right? It's not going to work for me. All right, cool beans. All right, how about this one? What if I said, let's just do a subtraction guy real quickly because I've been doing a lot of adding. So here's an example. And it says, one row, 2, -3, 5, minus 3, -2, 1. That also looks a little weird, but it just looks weird because it's only got one row in each of those. Okay. What's the size here? 1 by 3 columns, right? And what about here? It's also a 1 by 3. Okay. So can I subtract these? And you should be saying, yes, Dr. Webster, I can subtract these. And again, we're going to go element by element, but we're subtracting. So be careful. It's 2 minus 3. What's that? -1, right? It's -3 minus -2. Be careful because a minus and a negative makes that a positive. -3 plus 2 is -1. And last I got 5 minus 1, 4. Okay. What size is that guy? 1 row by 3 columns. So we're good. Okay. The matrices themselves look kind of weird, but the math, we can do it. We can subtract that, no problem. So even when they look a little bit weird, take the time and say to yourself, hey, what size is this matrix? And then compare. And if they are the same dimensions, is what they're called, same number of rows, same number of columns, same dimensions, then yeah, you can add or you can subtract. Okay. All right. Now, let's do a little bit more complicated type examples. And I'm going to say there are some examples that are word problems on this. That'll be on the video with the multiplication problems because I'm just wearing down fast. Okay. So this guy says, hey, you've got two matrices. There's a 3, -2, 5, 0, minus the other matrix is -2, 2, 3, 4. And that's equal to, and that's going to be interesting, equal to, on the other side, I've got also two matrices. 3, -2, 5. Oh, I'm so sorry. I'm such a weirdo. I should make that an equal sign. Eh. It is not equal to that. That is my problem. Sorry. That is my question. Okay. I did a run on. See, I told you I'm getting tired and weird things happen when I get tired. Okay. So we just need to solve this. Okay. So I'm going to just work it straight through, but realize that with this minus sign out here, if you wanted to, you could distribute that through to all of those terms there and make it work. Okay. I'm just going to work it step by step, position by position. This is a 2 by 2. This is a 2 by 2. I can subtract these. I will be good. All right. So 3 minus -2 is a 3 plus 2. That's a 5. -2 minus 2 is a -4. 5 minus 3 is a 2. And 0 minus 4 is a 1. Okay. Check real quickly. Is that a 2 by 2? Yep, it's a 2 by 2, so I'm good. Okay. So that's what it looks like. If you wanted to, though, you could have distributed. And when you do that, when you distribute, you would make it a positive, right? This becomes an addition problem when you do that. Okay. This is the problem I thought I was looking at, and I just jumped the gun. Okay. This says, everybody's okay with that, I hope. I'm moving on. Okay. This says, sorry, things have started happening. A, B, C, D is one of my matrices minus the next matrix is 2, -1, -5, 6, and that equals the matrix 4, 3, -2, and 4. Okay, so I can't really do anything with the equals part of this yet. But I can see what I can do with the left-hand side here. So I need to see if I can put this together. This is a 2 by 2. This is a 2 by 2. So yes, they have same dimensions, so I should be able to subtract these. It's just going to look a little weird because I've got variables in there. So in this first position, I've got a minus 2. Okay. In the second position, first row, second column, I've got b minus -1. So that's what? B plus a 1, right? Okay. And then here I've got c minus -5. C minus -5 is the same as c plus 5. And then I've got d minus 6, right? Okay. Now, before I can go on to solve this guy, remember what we said at the very beginning of this section. If they have the same dimensions, I can set them equal to each other and I can solve. Okay. This is a 2 by 2 and this is a 2 by 2. So yes, I can set them equal and I can come up with stuff that gives me these little equations. And that's what I'm going to do. So when I read this, I see a minus 2 equals what? 4, right? And I see b plus 1 equals what? 3. And c plus 5 equals -2. And last but not least, I see d minus 6, d, equals 4. Okay, so what I have here, they're kind of weird, but we can deal with it. I have 4 little bitty equations that I can solve. The a is going to equal what? Add 2 over, so a equals 6. The b is going to equal, subtract 1 off, 3 minus 1 is a 2. The c is going to equal, subtract a 5 off, -2 minus 5 is -7. Okay. And the d is going to equal, add the 6 over, 4 plus 6 is 10. Okay. So sure enough, we can solve those. And if you wanted to, you could come back and put it into this equation or this matrix, 6, 2, -7, d. That is my solution matrix, right? Okay. Or this is a solution to. Either way would be wonderful. All right. That's it for adding and subtracting matrices. This homework, it was section 4.4. It has the multiplication in it also. So you can start on the homework, but if you see those multiplication problems popping up, don't deal with them because that is a completely different piece of this puzzle. And I will get that video made ASAP. All right. Thanks so much. Let me know if you have questions.